Unit 1, Section 3, segment measurement using various methods. So we are going to, in this section, we're going to measure some line segments. There are 3 different ways we're going to do that. And let's get to it. Start with some vocabulary. There's a distance formula we're going to learn about. It's a formula that allows us to find the measurement of a line segment when we have 2 endpoints. So this is when we don't have a line in front of us that we can just measure with a straight edge. This is when we have to actually find the measurement of the line using the points. Points like you remember graphing in a coordinate plane, x comma y. That's a coordinate pair, and that's what we would use, 2 of those, to find the distance formula, or to use the distance formula to find the distance. Collinear. Collinear is when 2 points are on the same line. So co is together, and linear stands for line. So this is one line with 2 points on it. Most of the time with line segments, you're going to find the 2 points, the 2 end points are collinear. And then midpoint. Of course, we've already heard this. This is the middle of any line segment. So we can find the distance between 2 points in 3 different ways. As I said earlier, we can measure. We can use a straight edge to measure the distance. We can use an equation. We know algebra, and so we can use algebra to help us figure out an x or even the distance of the line segment because we are able to solve for variables. And finally, the distance formula, which is the formula that you see right there. It might look a little complicated. It's not so bad. It's really not that different from finding your slope when you used to say x minus x and y minus y. If you see, it's very similar. It's almost the same formula. We just have a square root sign, and we're squaring both of them. So let's go to examples. We're going to start with measuring the line segment that you see. There's a black line segment here, and I have a ruler that is close to a real size ruler. It may not be exactly perfect. This is for demonstration purposes. But if I use the ruler to measure, it says for me to measure in millimeters. When you measure in millimeters, it's the teeny, teeny, tiny tick marks that are here in the ruler. All these little tick marks. There are 10 millimeters for every centimeter. So when I see a 1, it's actually 10. Or if I see a 2, that's the centimeter, but the millimeters, they would be 20. So using that, I'm going to take a minute because it's really hard to see exactly. So I'm going to take a minute to sort of draw the line as to where my line is. And then I look and I see, okay, so that's in between 8 and 9, which would be 8.5. But if I'm going to times that by 10, I would get 85. So it says round to the nearest millimeter. I'm going to say that this is 85 millimeters long. All right. So we're going to get rid of the ruler now. And we're going to go to example 2. Example 2 has some algebra in it. You can see that there's an x and it says solve for x. We can also see that it does tell us how long this line segment is. So we're not actually measuring this. We're trying to find the x. Well, if we know that this part and this part together make x, well, then we can add them and solve for x. I'm going to set up the equation. Why don't you pause the video and try to set it up yourself? Think about it. You're adding these 2 parts together and they're equaling 16. So try to set it up and solve it yourself and then check and see if you and I agree. Okay, hopefully you set up your equation. You paused the video and set up and solved your equation. If your equation looks like mine, x is equal to -10, we were able to use our algebra skills to solve a geometry problem. All right, let's go on to example 3. Example 3 asks to use the distance formula to calculate the measurement of a line segment with the following endpoints. All right, so if we're using these coordinate pairs, we know that this is x, this is y, this is x, and this is y. Okay, so I'm going to go ahead and set up the distance formula. Once again, pause the video, go ahead and set it up for yourself, and then check and see if you are doing it the same way as me, and then we'll solve it together. All right, so if you look at this, this is how it's set up. You've got your x2 minus x1, and then you're squaring it. Then you've got your y2 minus y1. Now remember, when we minus and negative, like we are doing here, we want to make sure that that actually turns into a positive. So if I were to solve this, I would say 2 minus 8 is negative 6, but I'm squaring that. And then 2 plus 6 is 8, and I'm squaring that. Negative 6 squared is 36. 8 squared is 64. Remember, this is still all under the square root sign. 36 plus 64 is 100. Ooh, nice. So 100 is a perfect square. That means that when I square root that to solve it, I get that my distance is 10. We did not get units here, so we don't need to write a unit as an answer, but we know that our distance is 10 because we used the distance formula to do that. Now remember, this is when you don't have a line in front of you. You can't measure it. You need other ways to solve this problem. Example 4, we're using the distance formula to calculate the measurement of this line segment. Now, this time it's actually drawn on a graph for us, so we're going to need to go in and figure out what these points are and set up the distance formula once again. So I'm going to let you do that, pause the video and set it up, and then we'll talk about how it's set up and solve it together. All right. If you watch, you'll see I made a few mistakes and I fixed them. First, I wanted to make sure I wrote the points down, the coordinate points, and I did that by just looking at where they were. X is always first, y is second, so that's the first one is 1, 2. X is 1, y is 2. The second one is 2, and then we had a negative 5 for y. So then when I go down to the distance formula, I say my second x minus my first x, and then I have my second y minus my first y. So when I continue to solve this, I say 2 minus 1 is 1. 1 squared is 1. And then I've got negative 5 minus 2. Well, that's negative 7. Negative 7 squared is 49. All right, so then my total is 50. And this is not a perfect square. So when I don't have a perfect square, I can either leave it as the square root of 50, or I can think about a perfect square that's inside of 50. 50 exists because of two, well, more than two, but some factors. And 25 and 2 are two factors that make up 50. 25 is a perfect square. I can square root that, bring it outside, and leave the 2 inside the square root sign, and that can be my final answer. Either way, whether you leave the 50 or whether you take the 5 out and you do the square root of 2, those answers are both completely appropriate for geometry. All right, so there's some exit ticket for you to try. Go back and look at what we did in the video. Good luck.